Hello everyone. We are going to see phenomena of interference when we introduce a thin transparent plate, see in the box, in path of one of the interfering beam of light. So here in this interference pattern we will try to see what is the effect when we keep a thin transparent plate in the path of one of the interfering beam. So see very carefully how. Let us consider here we have two virtual source S1 and S2. Here let a screen is kept here. If here given 2d is the distance between the virtual source and capital D denotes the distance between virtual source and screen. From here let beam of light moves from both virtual sources S1 and S2, and in the path of S1 a thin transparent film is kept here in it, and after crossing this ray of light meet at point P and the phenomena of interference takes place. Let this point is O. So distance from here represent as xn. Now see carefully that thickness of the thin film is D. So here small d denotes thickness of thin film, and let mu denotes refractive index of thin film. Then refractive index can be given here is c by v, because c is speed of light in vacuum, and v denotes speed of light in medium. So refractive index of thin film mu is given by c by v. Clear it is? Now see the monochromatic beam reaching on P and phenomena of interference takes place here in it. Now see very carefully here in it. Light travel in air or vacuum S1P minus d distance in air and d distance in medium, transparent medium. So since the velocity in both is different, the speed of light in air is c, and in this medium speed of light suppose v. So time taken different. So we are going to take a time taken to travel a ray of light in air. So time taken to travel the beam of light from S1 to P in air is equal, let this time is a t1 is equal to, time is equal to distance by speed. So distance is S1P minus distance d by velocity in air is c. Let it as equation. This equation represent as 1 and this is equation number 2. and we are going to calculate time to travel in thin film. Let this time is a t2, distance traveled in that is a d, and speed is a v. We can change here, since we know that mu is equal to c by v. This implies that 1 by v is equal to mu by c. So keeping this t2 time can be written as, in place of 1 by v, when we introduce mu d by c. C it is. This is equation number 3. Now we are going to obtain total time. Total time from S1 to P is, let T, it is T1 plus T2. This is T1 is S1P minus D by C plus mu D by C. Then one may write this is S1P mu minus 1 into D by C. C it is the total time, and it can be given by equation number 4. Now one thing is a very important, time S1P mu minus 1 into D plus C. Herein is, let us see very carefully, this time we know it is a general formula, distance by velocity. Now compare with the diagram. If thin transparent film is not introduced here in the path, then it has to travel only S1P distance. But after introducing the thin film, see very carefully, it has to travel extra path, mu minus 1 into D. This is a distance, numerator is distance, S1P plus extra it is. So one may write, when thin film is introduced, light has to travel extra path. Extra path how much? Mu minus 1 into D. Light has to travel extra path. This is. Now we are going to obtain path difference. In this case, see the path difference. We are knowing the longer path in the diagram is S2P. S2P minus the path travel, distance travel by the beam of light from S1 to P. So see carefully here. Longer path S2P, this is S2P minus the smaller path is S1P plus mu minus 1 into D. So one may write S2P minus S1P minus mu minus 1 into D. It is path difference. See it is equation number 5. This path difference here noted as effective path difference. But since we know that in the Young double slit experiment, when we obtain this path difference S2P and no thin film introduced, that is when D is a 0, no thin film introduced. No thin film. Then it came, it must be clear to everyone, 2d xn by capital D. We know. Let this is equation number 6. Now what we are going to do? We are going to place a value of S2P minus S1P in equation number 5. Let's see what happens. Then this is equation number 6 is here. Now path difference effective can be written as, putting this value here, is 2d xn by capital D minus mu minus 1 into d. This is, let this now equation number 7. Now we know that the condition of bright fringe what is this? Condition of bright fringe is path difference effective is equal to n lambda, where we know n is equal to whole number 0, 1, 2, 3 and so on. In that condition, what is the path difference? 2d xn by capital D minus mu minus 1 into small d is equal to n lambda. Keep differences between the both d. Let us see this d is a d dash. Then see here in the derivation everywhere, it becomes d dash. And this is d dash. Now see here, in this finally, it is here d dash. See again, to bring a difference between both d here, treat this d as a d dash. So here in the derivation, it will be d dash here, this place also, followed by here, this place, here, here, every places where we have kept d. Now for center fringe, n is equal to 0. Then when it is placed n is 0, these equations can be written as 2d xn by capital D minus mu minus 1 d dash is equal to 0. This implies that one may obtain. So if you are keeping n is 0, then xn is treated as x0. So here becomes x0. Then this implies that here x0 is equal to capital D by 2d n minus 1 into d dash. Let this is equation number 8. Now see very carefully, if no thin film introduced, then position of center fringe, then position of center fringe x naught is equal to 0. It means in absence of this thin film at center, the bright fringe formed. But center fringe, on introducing this, it is this distance from the point to center fringe. So one may write fringe shift is equal to capital D by 2D n minus 1 into D dash, where symbols have their usual meaning. Capital D is the distance between virtual source and screen. 2D is the distance between two virtual sources. This is mu. Mu is the refractive index and D is the thickness of thin film. Now, here in whole, two things are proved. One, on introducing the thin film, light has to travel extra path this much. One proof. And center fringe is shifted from its position origin D by 2D mu minus 1. It is mu minus 1 into D dash. So this is for the topic. Thank you and have a nice day.